So now we need to talk about domains of the trig functions. We now have the trig functions defined for all real numbers, except that we noticed that there were some places where they're not defined because you would be dividing by 0. So we need to know what the domains are. That is, the domain will be all real numbers except for those points where you would be those angles where you would be dividing by 0. Okay, so for sine x, the domain is all real numbers, and for cosine x, the domain is all real numbers. That's because you're always dividing by the hypotenuse of that triangle, right? And so you're never dividing by 0 because that's a positive number. And of course, for the special angles, we know we always get these are just the coordinates of the first and second coordinates of the point on the unit circle, right? Which you can always find. So those ones are easy. Tangent x, well, you don't want to divide by 0. Tangent x is sine x over cosine x, and so you need to eliminate wherever you would be dividing, where cosine x would be 0, which is when c would be 0 on the unit circle, right? Where c is 0. And c is 0 on the s-axis. Right, and this same thing is going to happen with secant. Secant x is 1 over cosine x, so it has the same denominator as tangent x. And so it has the same problem points. Okay, so I have to have cosine x not equal to 0 for both of these, which means that c is not 0, which means that x cannot be, the angle x, cannot be pi over 2 or negative pi over 2, or any of those adding 2 pi. And that amounts to the same thing as saying it's not pi over 2 plus any integer multiple of pi rather than 2 pi, right? So like this is pi over 2. That would give me a c of 0, so I would be dividing by 0 for tangent or secant, and I can't do that. So I can't use this point, and I can't use this point down here either. And that's pi away, right? It's always pi away. So that's why instead of 2 pi, there's a pi here. So I don't have to list pi over 2 plus 2 pi k and negative pi over 2 plus 2 pi k. You can just simplify it and just write it as pi over 2 plus pi k, where k is an integer. So x cannot be those numbers. It can be any other number because c can't be 0. So it looks like this. I do a diagram. Sometimes it's easier to remember these from these diagrams. So that's the domain. It means the terminal side can be any side that intersects the unit circle at any point except for where those open dots are, which is on the x. It just can't be on the s-axis, right? Wait, did I do that backwards? No, that's right. Can't be where c is 0, so it can't be on the s-axis. Okay, so cotangent of x and cosecant of x both have sine on the bottom. Cotangent x is cosine x over sine x, and cosecant x is 1 over sine x. Right? So we can't have s equals 0. Sine x can't be 0. So s is 0 on the c-axis. So I can't have my angle x can't be on the c-axis. So that means that x is not an integer multiple of pi. Right? Remember, 0 is an integer. So 0 times pi is 0. And then 1 times pi, 2 times pi. So 0, I'll do it here. 0, pi, 2 pi, 3 pi, 4 pi. I have to eliminate all those angles from my domain. And same thing with going in the negative direction. So that's just pi times k, where k is any integer. So x is not those. And that looks like this on a diagram. So I've just got the whole unit circle, except I can't use angles that are on the c-axis. It's that simple, okay? And if you remember that from the diagram, then you can figure out what it is. I don't actually have these memorized myself. I just figure them out each time to draw a little diagram. There's too many things to memorize things like this, I think. But if that helps you, that's fine.